Okay, so on page 13, continuing the example, let's put in the probabilities from the table. So less than 0.5. 0.5 is here. So 0.6915. And then the probability that we are less than 0 is going to be 0.5. Less than 0 is 0.5. Then Z negative 0.25. So go to your table. Negative 0.2, and the fifth one is here, 0.4013. Okay, and in my calculator, I got that to be 0.24. I rounded to 2 decimal places. So answering the question, 24% of the time we get an infringement notice if alpha is 1. But my vehicle speed is not actually over 80. Part II is very similar to I, except they've changed the value of alpha. Okay, so the table then becomes, here's your error. 2 is still 0.5, so that works out to be the same. And 2 plus alpha, if you plus negative 3, that'll be negative 1. You get 0.5 there. So the first part here, sorry, that should be probability. The first part here matches the exact same as the beginning part. So basically this first term here will be over here as well. So half probability between 78 and 80. Okay, and then we've got plussing probability now. This is an error of negative 1. So remember that the actual speed detected is going to be x plus the error. So that'll be x plus negative 1 being the detected being greater than 80. That's the speed detected. Greater than 80. And my speed was actually less than 80. That's what the question's after. That the detected was greater than 80, but my speed was less than 80. Convince yourself that these two things don't work together, because this would represent x being greater than 81 and at the same time x being less than 80. That's impossible. So the probability of that happening is just 0. So that term becomes 0. That's kind of nice. Okay, so the question just becomes this particular term here. And if you follow through our previous working out, we got z-score between 78 represented a z-score of 0. And 80 represented a z-score of 0.5. And then we can use less than 0.5 minus probability of z less than 0. Okay, and then we can sub in the values we've already got from the previous part. So it's going to be 0.6915 minus 0.5. And when I did that in my calculator, I got 0.09575, which is 9.6% to 1 decimal place. Okay, so that was the answer for the second part. Okay. All right, the difficult part, part D. Find the range of values of alpha such that the probability that an infringement notice will not be issued. Okay, so an infringement notice not being issued means that speed detected must be less than 80, but, I'm going to treat the but as and, the speed of the vehicle is actually over 80. We want that probability to be at most. So at most will mean less than or equal to 7.125%. So let's think about how to write this. So probability that the speed detected is less than 80. And at the same time, my actual speed was more than 80. we want that to be at most, so less than or equal to, because it's at most 7.125% or 0.07125. Okay. So that's my setup. Okay. Now let's work on splitting this up. So we're going to use this table here. So let's go. And remember that speed detected is x plus e. Speed detected is x plus e. I'm going to use that. So a reminder, the table looks like this. 2 and it's 0.5 for probability. And that's 2 plus alpha and 0.5. Okay, so half the time the speed detected is x plus 2. And then half the time the speed detected will be x plus and then 2 plus alpha. The first guy is a bit interesting because this says x is less than 78 and x is greater than 80. That's obviously impossible. There's no way for you to be less than 78 and greater than 80. So that guy goes to 0. So that term basically disappears and we can focus on this term here. Okay, I'm just going to remove this table and include my inequality. Okay, so I'm going to rewrite that, I'm going to times by 2 and rewrite that probability. Actually, let me just make x the subject first. So that'll be 80 minus 2 minus alpha, and at the same time I'm greater than 80. And if I times this guy by 2, you will get 0.1425. Okay. All right, so rewriting this guy like this. And then remembering that when we've got probabilities between two scores, we subtract. It's going to be x less than 80 minus 2 minus alpha minus p x less than 80. Now, 80 represented a z-score of 0.5. We've learnt that from a previous part. So I'm going to just rearrange this a little bit. I'm going to bring this guy over here and change him to 0.5. As I said, less than 0.5. And we've got the plus 0.1425. Z less than 0.5. 0.5 there, 0.6915. Okay, and we get that this has to be less than 0.834. Then we've got a probability. We know what the answer to the probability should be, so we can use the table in reverse. Use table in reverse. So probability of 0.834. Let's go through. 0.834 is here. 0.97. Okay, so that means that this guy here represents probability that z is less than z, less than or equal to 0.97. Okay, or rather, I'll just write it as z. The z score has to be less than or equal to 0.97. That's a better way. So we've got a score. My x score is going to be 80 minus 2 minus alpha, and we want the z-score to be less than 0.97, so substitute in to the z-score formula x minus mu over sigma. So that's going to be 80 minus 2 minus alpha. The mean was 78. Standard deviation was 4. Okay, collect like terms at 78 minus 78 goes away. Okay, timesing by -4. We're timesing by negative, so flip. And you get that alpha must be greater than or equal to -3.88. Okay.